Um, if I seem like I'm going a little quick, it's because again, my assumption is not that you're seeing these problems for the first time, but rather that we are merely here just to make sure we already did them correctly. So for the first line, I would go up 9, which is right here. And then my slope is up 1, right 2. But again, that is not sufficient. As I just said, if you graph the line right there, chances are your line's going to go off kilter. So since I have enough room, you guys understand that a ratio of 1 to 2 is the same as a ratio of 5 to 10, right? You learned about equivalent fractions back in the day. So if instead of going down 1 and left 2 a whole bunch of times, I could go down 5 and left 10. A lot of you probably already figured that out, but like you can save time graphing if you just mess around with fractions. So this particular line should go like this. Okay, our second line, I would start at down 1 right here, and its slope is down 2, right 1. So I can go like down 8, right 4. I mean, if that makes you uncomfortable, then just keep doing it the way you always have. Just do a whole bunch of points, right? Or if I go up 10, how far left do I have to go?
Like
Well, if I keep going up 2, left 1, up 2, left 1, up 2, say it again. Correct. The correct ratio is 10 to 5. So all I'm just trying to say is you don't have to graph every point. You just have to graph the ones that are the furthest apart on the grid. So if we graph those lines or those points,
you make like little peaches guys.
right? So we're going to have this, and then we're going to circle the point where they cross, and then we're going to name it. And the name of the point is -4, +7. So the answer to the problem should be this, -4, +7.
Oh, that's what.
Are we perfect so far? Let's play a game of Survivor and see who the last one to make it perfect is. So everyone's still perfect. All
I
right.
did not get that.
Uh-oh. One's
I
out.
okay.
-1. Um,
Oopsie.
I tried to throw some curveballs at you here. So I didn't want all 4 of these to be the same. So I wanted them all to have their own lifeblood, their own purpose. And problem 1, there's a couple ways you can approach this. Number 1 is you can do the old standby. I mean, this is just a classic substitution problem. You could take this and put it in a box, and then you can put it right there.
Um,
You can also employ some logic to this. You can make this feel less mathy and just use some basic common sense. If 4x minus 5 is the same as y, and -2x plus 13 is the same as y, then those two things have to be the same as each other. Regardless of whether you take the common sense approach or the very literal make a box, put it in kind of approach, you're going to wind up inevitably at this conclusion that 4x minus 5 has to equal -2x plus 13. This equation should be on your paper no matter what. And then when we solve this, it should go pretty quickly. I'm going to add the 2x across to get 6 of those. I'm going to add the 5 across to get 18 of those. And then I'm going to divide by 6 to get 3. And then you can put 3 wherever you want. So like, for example, if you put 3 like right here, 4 times 3 is 12. 12 minus 5 is 7. So y has to equal 7. Therefore, the final answer to the problem is 3, 7. Are we still perfect?
I actually don't know why we're wrong.
Did you make a box?
Yeah, I made the box.
Where'd you make the box? What'd you put in the
4x minus
box?
5.
Okay, and then you put that in place of the other y.
Yeah, so it's 4x minus 5 minus 2x plus 14.
You need to have an equal sign. Look up at the TV.
Yeah.
Don't upset. There's no time for that. But you need to have those two things that you have, but they need to equal each other. When you copy that down, there's an equal sign. Okay. You okay? On to problem B. The trick I tried to throw at you here was I tried to give you choices. And generally, I haven't given you choices. I've made one variable attractive. I gave you 2 this time just to see how you'd react. The one on the bottom, the y, you shouldn't be attracted to because it's got a minus. But the 2 on top, I just wanted to see how you'd respond. It's not a problem if you have more than one option, right? You could get x by itself by moving the y. You could get y by itself by moving the x. So I just wanted to make sure you're clear that that's obviously a possibility. I'll tell you that I'm going to try to do these the same way I did them on my answer key so that when I post it today after 7th hour, the things I'm saying in this recording will match what I have on um, Canvas. So I'm going to get x by itself. So if I take the top equation and isolate x, I get x equals negative y minus 9. And that is a classic perfect place now in time to put a box. Right? If I put that down in place of the bottom x, the bottom equation will say 4 awkward void minus y equals 4. And into the awkward void goes the box.
Negative y minus 9.
Yep. So I'm going to go resume. If you distribute the 4 through there, you get negative 4y minus 36 minus y equals 4. And you know by this point in the year that I like to do 2 steps at once right now. So I'm going to put my y's together, of course, to make negative 5y's. And then I'm going to add 36 to get 40. And then I'm going to divide. You all should have gotten y as negative 8. That is how that goes.
What if you did the opposite?
You got y by itself instead of x.
Yeah, I got y by himself.
Does your box up at the top say y equals negative x minus 9? Okay, then that's why yours is going to feel a little different. So yours should have you should have x equals negative 1 first.
Yeah, I got x.
Right, and that's just because you chose a different letter to box up. That's what I was saying at the beginning. You have some choices. So if you take negative 8 and put it right here, the negative of negative 8 is 8, and 8 minus 9 is negative 1. So x is negative 1. Bottom line, at the end of the day, we all should have arrived at this conclusion. Negative 1, negative 8 is the answer. That is it. All right, problem C. I don't really exactly remember what my goal was. I think this was the only one of the 4 where I just said, here it is, just standard old school problem. There's very little fanciness here. The top equation is obviously the one that I'm steering you towards. So x is going to equal positive 5y minus 17. By the end of February, our days of forgetting to change signs, they should be so long over. So positive 5y minus 17. You're going to put that back in place of x, and it's going to say negative 4 minus 8y equals 12. And then as always, into that void goes whatever we have in the box. From this point, the next minute of our time together has nothing to do with anything that we learned any time past the middle of September. It's just an equation, and we don't mess these up, right? We distribute correctly, so that's negative 20. That's positive 68. And then we do 2 steps at once a lot of times here.
Combine.
My y's make negative 28. I subtract 68 from positive 12, giving me negative 56, and then I divide to get y equals positive 2. And once I know y is 2, I just take it and put it right back up in the cute little box and do some little kitty math. 5 times 2 is 10, minus 17 is negative 7. And if those are my 2 values, then the answer is negative 7. Question D has his own life and existence on this test because D doesn't so much test, do you know how to do elimination? D very specifically tests, do you know what to do when all of the variables die? Not just the one you're trying to get rid of. We've seen this before. We did an entire assignment on this particular thing. So here it goes. This is just business as usual for now. Y is already by itself. How friendly. So I'm going to box it up. I'm going to put it in the other equation. I've done this 184 times. Bottom equation says 14x minus 2 blank equals 4. Nothing interesting yet. And then you put the box in there, 7x minus 2, and then you're still just mathing, half asleep through the process because you've done it so many times. And then it occurs to you that something weird is about to happen. But let's finish the job. That minus 2 has to be distributed at that minus 2, making a plus 4. And it's here that the problem will essentially end. When you combine your like terms, these x terms are opposites. They cancel, leaving us with this. And as I've said, this is no longer an algebra problem. This is a common sense problem. We simply assess the landscape and say, does 4 equal 4? Because the answer is yes, then what is the answer to the problem?
So,
It has
multiple.
infinite solutions. The way I wrote it on my answer key, I'm just trying to play like copycat here. I wrote infinite number of solutions. You can just write infinite solutions if you want. Remember, what this means really essentially is that they're the same line. We just have the same equation given to us twice. And of course there's infinite solutions because, well, they're identical. So page 2, let's have a gander. These problems are elimination. My goal, and I had my little tappity tap on the keyboard, I was like, man, I hope my students spot that the X's can both be made into 6s. I hope they're not monkeying around with the Y's. And so I said, gosh, if they just actually only multiply the top equation by 2, we're done. What does that top equation become if I multiply it by 2? Negative 6x minus 10y equals perfect. And just like that, that's a classic, simple level 2 elimination system where all I had to do was multiply one of the equations to make them eliminatable. And at this point now, the problem effectively is almost over. So when we add them together, the x's go cancel, bye-bye, boop. We get negative 13 y's. We get equals 39. We divide both sides by negative 13, and we are done with y. The only downside, I'll say it every time until I retire, of elimination to me is that at the end, you don't have that rad little box. Yeah, boo-hoo. But that's okay. So I'm going to take my negative 3 that is like half of my answer, and I'm going to put it in place of one of the y's. I can tell you on my answer key that I chose that one that I'm pointing at right there. Did I have to? Nope.
Nope.
Could you pick a different one? Yep. Don't care. This is how I'm doing it. So when I plug that in, I did 6x minus 3 times negative 3, which is really plus 9. So in this thing with the green arrow pointing to it right there, I did math to get that. I did the minus 3 times the minus 3. That's where that came from. And then I'm going to subtract the 9 from both sides to get negative 12. And then I'm going to divide by 6 to get x is negative 2. And then I build my answer. Question B, his only purpose on this test is to show me and whoever else wants to look at your test that you can do level 3. Okay. There are no level 1 elimination problems on this particular test. This is just a classic level 3. My options when I look at this problem are I can turn the x's both into 6s or I can turn the y's into 56s. And 100 out of 100 normal people when surveyed said, I'll take the x's, thank you. And so that's what I'm going to do. I'd rather work with 6s than 56s. So I'm going to multiply the top equation by 3 and the bottom equation by 2. And that's going to result in, I'll write over here, 6x plus 21y equals negative 42. The bottom equation is negative 6x minus 16y equals positive 22. And this is where I draw my line because I say, good to go, going in. And it's just this is as classic of an elimination problem as a dude could possibly write. So when you add them together, the x's go poof, you're left with 5 y's. And negative 42 plus 22 is negative 20. You divide by 5, and y is negative 4. And as always is the case, you got to plug it back in. I mean, again, to be Mr. Matchy Pants over here, when I worked this out last night, I chose the top one, the top original, obviously. So the way you would see my work is I did 2x minus 28 equals negative 14. And I'm going to say this before anyone asks. This minus 28 is the result of the math in the green circle above. There was a 7 times y. I changed y into negative 4. I multiplied and figured I'll just stick the answer there. And then I added 28 to both sides, and I got 2x equals positive 14. And then I divided by 2, and I got x equals 7. And then I wrote my answer. I'll write it in yellow. right here. The answer is 7 for x. I got 4 for y. Why does question C exist on this test? If you're the math teacher, why did you put it here? To make sure you know how to move stuff around, right? Make sure you understand that like elimination ain't happening when stuff's all over the place. Like you can't just start going ham on this. Like, you don't know what you're doing. So I'm going to be pretty deliberate about this. Quite frankly, a little boring. I'm going to take the X's and Y's and move them to the left. This is my choice. So I'm going to take the 7x, add it, make it positive. I'm going to take the 4y, move it, make it negative. I'm going to take the 8, move it, make it positive. Did not have to do that. That's just what I like to do. Now I'm going to take my second equation and I'm going to say negative 4x. I like you right where you are. Minus 3y, not so much. So I'm going to add you back across and make you positive. And then the positive 1 over there, I'm like, what are you doing over here, homie? Get out of here. So I'm going to move it and make it negative 1. This is the setup. And then it's just a classic problem. Again, you have to think to yourself, if I surveyed people, normal people, and said, would you rather work with 28s or 12s? Most people are going to say 12s because 12 is smaller. And humans are not dumb, right? We're like, I'd rather work with smaller numbers. So my choice is to kill the y's. So I'm going to multiply the top by 3 and the bottom by 4. That's going to morph my system into 21x minus 12y equals 24. Negative 16x plus 12y equals negative 4. And this is where I draw my line and say, I'm going in. So let's finish. When we add them down, the y's, of course, cancel. How many x's are left? 5. And what's 24 plus negative 4? Now it's positive 24 and negative 4, which makes 20. Right? There's no negative on that 24. And then we divide by 5 and we get x equals 4. And for the third straight time, I will say, put it wherever you personally want to. I will tell you that I put it in this one that I'm circling in green. So when you see my work, it will say 28 minus 4y equals 8, because I did 7 times x while I was there. I subtracted 28 and I got negative 4y equals negative 20. And then I divided and I got y equals 5. Last job is to, hit full send, write the answer, 4, 5. You know the answer to this question if you've done it. Why does question D exist on this test? It's a special case. I've already, by this point on the test, tested your ability to do elimination. I know by this point that you do or don't know how to do the process. What I want to know now is, okay, so you know how to do elimination. Do you know what to do again when all of the variables naturally self-eliminate? So let's take a look at part D and then we'll get on to the rest of this. So again, you just got to think about playing the odds. What would you rather work with? Turning 7s and 6s into 42s or turning 14s and 12s into 84s? It's an easy choice, right? And so we're gonna kill the y's by multiplying the top equation by 6 and the bottom equation by 7. Okay. So my top equation is going to be 84x minus 42y equals negative 48. My bottom equation is negative 84x plus 42y equals 84. And it just happens again. It was the same thing as with the substitution. I'm just carrying on minding my own business when suddenly something unintended happens. I intended that. I did that to the y's. What I didn't intend, who came along for the ride, was that the x's also happenstance eliminated. And so this becomes what we call a special case. When the entire side of an equal sign destroys itself, you have to put a number there, 0. And then we're just going to play a little third grade game of compare the numbers. The number on the right is negative 48 plus 84, which is positive 36. And we just have to ask ourselves, does 0 equal 36? And the answer is no. Therefore, there is no solution. That means, what about these two lines if we were to graph them? They're parallel. These lines can never cross. If they were going to cross, we would have found it. But if they never cross, which that's what that says, they have to be parallel. So that's what they are. This one, number 4, should be just pretty fresh because I think we did quite a lot with this. We did a lot. So you would declare your variables. My first one, I would say let H equal cost of a hot dog. Your variables might be different from mine. Let D equal the cost of a drink. As I've said before, I'm not really worried about whether or not you like that step. So just, yeah, think that step is lame. Yeah, still got to do it. All right, and then we're going to write the equations. And so the first one was very nice of you. You're a good guy. The first equation is going to say 4 hot dogs plus 3 drinks is equal to 23.23. The second equation is going to say this one's for Sarah, 2 hot dogs plus 4 drinks equals 1834. Do you have any questions so far? Okay, so that's the setup. At this point, I tried to lob a softball right to you. If you did anything other than what I'm about to do, you missed the free gift. I really wanted you to multiply the bottom equation by -2. All right, I tried to make that as easy for you as I could. And that is that if I just change the bottom equation, then I'm good to go. So if we multiply by -2, our new bottom equation becomes -4H minus 8D equals -$36.68. Good. At this point, just kind of to make a point, I'm going to show you that you really need to ignore that middle equation for like the next 30 seconds. Okay. So I'm going to draw my line and I'm committed, and here I go. When I add these equations together, the H's cancel. I did that on purpose. 3D minus 8D is -5D. If you add those numbers together, you get -1345. That's it. Divide. I mean, you got divide. D is, what does it come out to be? 3,269. What do we do now? What do we do now? Plug it back in and go find H. And where you do it for the 912th time is your own business. I will tell you on my answer key what I chose. I chose the one I'm circling in green. So when you see my work, that's what I'm doing. I went to that equation and I changed D into 2.69. And it's going to say this. It's going to say 4H plus 8.07 equals 2323. Got it? I just multiplied. That's all I did. And then when I subtract the 8 across, I get 4H equals 1516. And then I divide and I figure out that H is 3.79. What's the last step in this annoying process? Answer the question, right? So your answer would be, in the interest of time, I'm not going to write it. It would say a hot dog costs $3.79, comma, and a drink costs $2.69, period. Capital on the front, period on the back. That's that. Page 3, we should be able to cook through this just because, man, talk about something that is just what we did recently. So any issues, let me know. Based on your quiz scores, I'm going to guess that we're not having a lot of troubles with this particular page, nor the last page. So here I go. I'm taking my own test right now. I'm going to say, okay, I see the +5. I'm going to go up 5. I see the slope of -4/3. So I'm going to go down 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go right 6. 1, 2, 3, 4, 5, 6. Remember, a ratio of 8 to 6 is the same as a ratio of 4 to 3. And just because I want a little more to work with, I'm going to fudge another point. I'm going to go down 1, 2, 3, 4, right 1, 2, and just guess that there's one probably right there. Just freestyle a little bit there, but I like as many points as I can. So this is the line. Do you like my line? Do I have to change it? Make it dotted?
No.
Nope, not
It's
this
solid
time.
because it's
Absolutely. So all I need to worry about now is the shading. And does the shading go above or below?
below.
Below, because it says less than. And so my shading is just going to go down here. That's it. Okay, on the second problem, what kind of line only has an X?
It's
A vertical line. So I'm going to go to -4 on the x-axis and I'm going to make a line. And do I like this line? I shouldn't.
it's dotted.
So I'm going to go back and fix my line and make it dotted like this. And which way will the shading go? To the right, because greater than is obviously to the right. Very good. And so I'm going to shade over here like this. Any questions on that? Okay, numbers 6A and 6B. Same thing. You guys are proving you're pretty good at this whole graphing thing. So we're going to go down 4. What's the slope? 2/3. So I'm going to go down 1, 2, 3, 4, right? 1, 2, 3, 4, 5, 6. And then likewise, I'm going to save time. I'm going to go up 1, 2, 3, 4. I think that's probably all I can do. And then left 1, 2, 3, 4, 5, 6.
Yeah.
That's positive. Gosh, I think I owe myself $50 for that. So I'm going to go up 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 2, 3, 4, 1, 2, 3, 4, 5, 6. By the way, the fact that you guys just jumped all over me really makes me happy. I feel like that's a great accomplishment. So thank you for keeping me in line. Warms my heart. So I'm going to graph the line. This one is going to be dotted. So I'll fix that here in a second. Is my line okay now?
Yeah.
Okay, good. Thanks, guys.
Don't forget the dotted.
I got it. Nailed it.
You fixed it.
Where would the shading go?
Above.
So remember, don't shade yet, just put arrows. Okay, I've learned about the colored pencils. That was a bad idea. I'm going to take that back for next year. Let's just draw arrows. It's better. The next one is going to be up 1. So I'm going to go up 1.
Up 1.
And what's my slope?
No.
Yeah, bottom line is it's just got to look like this. So just do a bunch. You can just, if you see my pen moving, I'm just following the one diagonal like that. It's a nice way to save time. So solid or dotted? Solid. So I can leave this one as it is. I don't need to modify. Where would the shading go? Above. So where the shadings agree, so to speak, or where they kind of come to a consensus is in the upper right-hand corner. So your shading should be above and then turn the corner. And then you have to pick a point. Sorry, I forgot about that. And so it does say pick a point. When you look at my answer key, I just picked a random one. You could literally pick anything. I picked 3, 2. How boring is that? Here's 3, 2 right here. 1, 2, 3, 1, 2. Boom. Lame. You could have picked like 56, 124,951. Like if you can predict that it's going to be in that orange green area, you're good to go. Be as boring as you want. Bottom line is it has to be in there. Let me ask you this, you big brainers. Could I have picked this point? Yeah, huh?
You could?
Why? Because it's solid, and solid means the points on the line count. So I could pick a point on a solid line if I wanted to. But generally, people stay away from that. They're just like, I'm going to pick a safe one. Boom. Here's a safe one. Boom. Here's a safe one. Boom. So whatever you want to do, just make sure it's actually where it should be. Okay. There are literally infinitely many correct answers to that part of the problem. All right. For part B, I need to just do the same thing. I need to graph me a couple of lines, nothing to it. So for the first line, I'm going to go up 7 and my slope is down 3, right 1. So 1, 2, 3, 1, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. There you go. That's the furthest you're going to get on that one. Solid or dotted?
Dotted.
Man, why do I keep making dotted lines? There we go. Where would the shading go, did you say? Down, which is over here. And then the other line is 1/2 of x plus 0, right? We're past the point where we don't see that. So we start at 0. And what is the slope?
Down 1.
Yeah, bottom line is it goes uphill and it's half as much up as it is right. So like I could go up 4, right 8. I could go down 4, left 8, like that. That works, right? That's a ratio of a half. I see you guys are kind of fidgeting and wrapping up. Give me just another minute or so if you'd be so kind, okay? So I'm going to make a line. Is it going to be solid or dotted?
Dotted.
This one also is going to be dotted. If you can really just wait a minute before you start coming up, that would be great, if you don't mind. Thank you. Bye. Shading is where? Above.
Zero.
So where the shadings come to consensus is here. And that's how that one should go. That leads us. Yeah, darn it. I forgot to pick a point again. Here, I'll just pick one. Bam. -8, 6. Got it? Pick whatever point you want. Last problem, finally, the multiple choice. There's really not a lot of trickery here for you. The only thing I would say is that you should have gotten the top equation y by itself. Like this. So that's really the prep work that is pretty essential. All of the lines are correct. What has to be true, though, is we have to be below the one with a slope of 1. So that keeps problems A and B in the running. We also have to be above the other line, which limits us now and says it has to be B. So you guys all should have picked B. Hold on a second. I'm going to pause this. I'm going to stop this.